Welcome back to the channel. Net positive suction head, or NPSH, and cavitation in pumps. Understanding net positive suction head, or NPSH, and its direct link to the destructive phenomenon of cavitation in ship pumps. These concepts are vital for maintaining the health and efficiency of any pump, whether it's handling cooling water, fuel, or cargo. At its core, a pump works by creating a low-pressure area at its inlet, or eye, to draw liquid in. NPSH is the absolute pressure available at the pump suction, measured in meters of liquid head, that is in excess of the liquid's vapor pressure at that specific pumping temperature. Every pump has a minimum required value, NPSH required NPSH score R, specified by the manufacturer. This is the minimum pressure needed at the impeller inlet to prevent the liquid from vaporizing. The value we calculate from the system design is available NPSH-A. For safe operation, the available NPSH must always be greater than the required NPSH, typically by a comfortable margin. The critical issue arises when the available pressure at the pump inlet drops below the liquid's vapor pressure, meaning the liquid is too close to boiling at the pumping temperature. This often happens due to high suction lift, long suction lines, or pumping liquids that are already hot, such as condensate or hot fresh water. When the pressure drops too low, the liquid instantaneously vaporizes, forming tiny vapor bubbles or cavities in the low-pressure zones near the impeller eye. This is the start of cavitation. The damage occurs shortly afterward. As these bubbles are carried slightly downstream by the flow, they enter the high-pressure zones of the impeller. Here, the surrounding pressure rapidly crushes or implodes the bubbles with tremendous force. This violent collapse generates localized pressure shock waves and microjets of liquid that repeatedly strike the metal surface of the impeller and pump casing. Over time, this repeated impact physically erodes the metal, leading to the characteristic pitting damage associated with cavitation. This damage significantly reduces the pump's efficiency, causes excessive noise and vibration, and ultimately leads to pump failure. To prevent cavitation, marine engineers must ensure keeping the suction lift as low as possible, minimizing friction losses in the suction piping, avoiding high pumping temperatures, and maintaining the correct fluid flow rate. Ensuring that NPSH is greater than NPSH is the simple, crucial rule for long-term pump health. If you found this video helpful, please give us a thumbs up, hit the notification bell, comment, like, share, and subscribe for more insights. Thank you.